Okay, so we go to the next question, question 2. Okay, so this question 2, okay, if you see here, okay, uh, is the second part, okay, of the single phase, okay, circuits, okay, which want you to find the apparent power, okay, which also want you to find the uh, improvement of power factor. Okay, so from this question, if you see here, okay, so the question give you, okay, 240 volt with 60 hertz AC supply fulfills the load at 10 kilowatt. Okay, so 10 kilowatt is the resistive load. Okay, with the 15 kilovar, which is capacitive load. Okay, and the 22 kilovar, okay, which is the inductive loads. Okay, so determine the appearance power, and then the question also asks you to get the current drawn from the supply, and also what is the kVA rating and the capacity required to improve the power factor to 0.9 lagging. Okay, so now we solve, okay, the problems. Okay, so the first one, okay, in order to get the appearance power, okay, we know that the resistive, okay, load is 10 kilowatt. Okay, so the capacitive, okay, is given as 15 kilovar. Okay, we put the minus in front of this capacitive load. Okay, and the positive inductive is J22 kilovar. Okay, so the capacitive, normally we put negative, right? So for the capacitive load, we put the positive. Okay, so the accumulation, okay, of this reactance load between the capacitive and the inductive, so we get the plus J7 kilovar. Okay, so for the S, we have 10K plus J7K. Okay, so the magnitude K for the appearance power is 12.21, okay, with the angles of 35 kilovar, or kilo VA. Okay, so the current, okay, the current drawn from the supply, okay, from what we have in the appearance, what we have, okay, for the appearance power, okay, we can use to get the supply currents. Okay, because we know that your S is equal to VI conjugate. So in order to get the I, okay, so we conjugate the S divided by V, right? So here, okay, so we have 10 plus J7 divided by 240 degree. Okay, so you get, okay, about 41.61 plus J21.17. However, okay, so the I here is the conjugate of this, okay, this equation, right? So you have, okay, 41.67 minus, instead of plus, okay, instead of you get the plus, okay, in the answer. Okay, so for the I is 41, okay, 0.67 minus J29.17 ampere, or if you want to, okay, convert in the magnitude, in the polar form, so you get 50.86, okay, with minus 35 ampere in angles. Okay, so what we can define, okay, from the currents that you found here, okay, the current is lagging the voltage, okay, by 35 degree. Or also, it can define as cos 35 is 0.81 lagging power factor. Okay, so the definition is from the civil, okay, the civil application here. Okay, the civil means, okay, C is for capacitor, I, okay, for the capacitor, the I, okay, leading the voltage. Okay, however, for the inductor, the V, okay, leads the current, okay, by certain angles. Okay, so from here, so what we have here, okay, the 0.81 lagging power factor. So we can say that, okay, the current lagging the voltage, right? So means it more it more in inductive load here, because the voltage leads the current is for inductor. Okay, I hope that you can understand. Okay, so we go to the next, okay, solutions. Okay, so the kVA rating and the capacitor required to improve the power factor, okay, to 0.19 lagging. Okay, so now we have to improve the power factor instead, okay, of 0.81, okay, from the answer that we found, okay, previously. Okay, so this is the general step, okay, that you can use or implement, okay, in order to do the power factor improvement, or to get the new capacitance, okay, to improve the power factor. Okay, the first step, okay, you have to find the QO for the old power factor. So okay, we know that our old power factor is 0.81. So you draw the triangle, okay, the P here, okay, for the real axis, okay, plus with the QO, right, because it's more inductive, right? So you have 10 plus J, 7, right, previously. Okay, so your PO is 10 kilowatt and your QO is 7 kVR. Okay, and then the next step, find the Q new for the new power factor. So for this question, okay, you have to improve, okay, your power factor into the new power factor. Okay, so the power factor that you have to improve is, okay, 0.96. Okay, so the P is maintained, okay, at 10 kilowatt. Okay, but now your power factor, your new power factor is 0.96, which equivalent to theta, okay, is equal to 16.26. Okay, so you have the remaining P, but okay, you have some variation of the Q here. Okay, so the new Q, okay, so you can use this formula, okay, P tangent theta. So the new theta here is 16.26. So 10K times with tangent 16.26. Okay, so you have your Q new is 2.91 kilovar. Okay, so this is your new Q. Okay, so the next or the following step, okay, is to find the deviation, okay, of the Q new and QO. So the deviation is the Q old minus Q new. So your Q old is 7K, right? Okay, so your Q new is 2.91. Okay, so in order to find, okay, the new capacitor, okay, you use the deviation of the Q, okay, which equivalent to 4.09 kilovar. Okay, so this is the important, okay, formula that in order to find the required capacitor in farad. Okay, so delta Q is equivalent to V squared divided by XC, which also equivalent to V squared omega C. Okay, so your capacitor here is Q divided by V squared omega C. Okay, and then we know that your omega C is 2 pi F, is 2 pi F. Okay, so you can use the frequency that given as 50 Hertz. So finally, okay, using this equation, okay, you substitute all the values that you got, okay, you will get, okay, the final answer, okay, for the new capacitor that you must put in parallels in order to improve okay, the new capacitor value into 0.95 is 188.35 microfarad. Okay, so now we go to the uh, okay, so with that for the next, okay, for the next slides, okay, I will show you about, okay, question 3. Okay, so I will use the next or the following video, okay, to discuss with you about question 3 and 4. Okay, so we'll see you again. Okay, so thank you.